A very warm good morning, my dear students. Today we are going to start with this. We are going to discuss about the limitation of valence bond theory, and most importantly, I am going to explain about the concept of back bonding, which is very much important according to JEE Mains, NEET, BITSET, and all that exams. In our CBSE, there is no much questions based on the back bonding, but it is important with respect to entrance point of view. Okay, so lots of questions can be formed by this. We'll discuss it later on. First, let's do this limitation of valence bond theory. Valence bond theory is it fails to explain magnetic nature of the molecule. Now you might wondering that what is the magnetic nature of this molecule. So that we will discuss later on when we will cover the MOT. Okay. Similarly, it fails to explain the different arrangement of elements towards central atom. That means resonance, which will be our next topic. Okay. That we have to discuss that how that molecule shows the resonance and how it gets the stability due to this resonance. Okay. This theory assumes that electrons are localized in specific areas. ये assume करता है कि specific areas में ही localize होते हैं. It doesn't give a quantitative interpretation of the thermodynamic or the kinetic stability of the coordination compound. You know the coordination bond I have explained, and there is a chapter in class 12 that is coordination chemistry. So where we will deal all about the metal and organometallic compound we will discuss. All the coordinate compound we will discuss, where the metal forms a coordinate bond with the ligands. Okay. So that is also that this topic we will discuss, we will know in class 12th. And there is no distinction between weak and strong ligand according to this concept, according to this theory. So now again the new thing that weak and strong ligand, what are they? So that all these 2 points we will discuss in class 12th. This is at the last of this topic, and here it is next topic. Okay. So these are the limitation of valence bond theory. Now this that much in this limitation. Okay. Now the very important concept we are going to discuss, and that is called back bonding. So as you can assume, you can think of it that back bonding, that means the bonding in backside. Yes. And if you see that एक हद तक ये सही भी है. Yes, it is going to make the bond in backward direction, in the backside. Okay. And lots of questions can be formed on this concept. Lots of questions. The question can be that bromine and aluminium both belongs to same group. Okay. So BF3 doesn't form the monomer, while AlCl3 forms the BF3 doesn't form the dimer, while AlCl3 forms the dimer. Why so? Similarly, lots of things are there that like PS3 and PF5, which one has more bond length? So lots of questions will be there that we will discuss, but in the later concept. So let me start with this back bonding. Whenever we take the name this back bonding, maximum 90% of students think of this only BF3. Yes, obviously it starts from the BF3, but it is not limited. It is not confined to BF3. It has a vast concept. Okay, vast things to understand. So anyhow, in our class 11th level, let's start with the BF3 and then we will go in detail. So if we talk about the BF3 hybridization, you all know that it is sp2, and how it forms. Let me explain the things. The bond angle is 120 degree. Everyone knows about it. Yes. And the structure is trigonal planar. Okay. Trigonal planar. If we draw that boron configuration, orbital wise configuration, we will get that 1s2, 2s2 and 2p1, isn't it? So let me draw the orbital wise configuration. I am writing only 2s. This is 2s2. And this one is 2p1. Okay. So this is 2px, this is 2p py, and this is 2pz. Any doubt in this? Okay. So in 2p it is only one electron. Now what will happen here in this case? We all know that in this case, whatever the number of unpaired electron, that much bonding it will form. So we can see that only one unpaired electron. That means one bonding. No, actually boron on the any atom in its ground state, it doesn't react. It exists like that. But when it goes in excited state, so what will happen if boron goes in excited state? Okay, so excited state, if we'll send it, what it will be? This one electron of boron will transfer to the next. Got it? So now it will be 2s1 and 2p1, 2px1, 2py1. Still the pz orbital will be empty. Okay, this is 2pz and this is 2s. So now boron has 3 unpaired electron, and now it will take 3 fluorine. Okay, and fluorine, if I'm talking about fluorine, it will take 1 fluorine. Yes, 1 fluorine over here in antiparallel direction, another fluorine in antiparallel direction, and this one. And so what it will form? It will form 1s and 2p. So it will form 3sp2 hybridization, isn't it? One here, like you can understand, 1s and 2p. So here also one, like it will form with this. So 3sp2 hybridization it will show. So let me draw the structure. If I'm drawing the structure for this, how it will look like. Okay, so let me draw the structure, how it will look like. Like this is sp2 hybridization. Okay, so like this we can make. Okay, so now this was the boron, and if we have to draw the fluorine, like fluorine, so what it will happen? Here it will, like this is fluorine. Okay, this will again, that here it will go and it will draw like this, and here it will be like this. Okay, so this is the hybridized orbital. Here it is going to be hybridized. Okay, like this. So this is forming what? sp2 hybridized. Now whatever the pz orbital jo hai yahan pe, this pz is still empty, so that is going to be like, it will remain like this. Yes, this is pz, 2pz, that will remain like this. Clear? Any doubt? And that is empty orbital. So if I will draw the structure, ye pura jo main draw karungi, to this will, I will get that boron, fluorine over here, and this fluorine over here, and this fluorine over here. So what it is? It is going to give you that trigonal planar structure, isn't it? Trigonal planar structure like this. And the empty 2pz orbital will be like this, isn't it? So this is empty orbital. Let me write empty 2pz orbital. Okay. Okay. So now you can see that it is, we know that octet, okay, octet molecule, because the one whose last electron, whose last shell is completely filled, 8 electrons. So similarly, this one is a 68 electron species. 68, that means it is having only what? 6 electrons. Okay. So it is in highly demand ki wo kisi tarah se it will get the 2 electrons and it will get the stabilization, isn't it? To complete its octet, this type of compound is also known as hypovalent compound. Why hypovalent? Because 8 should be there in the last shell, but it is having only 6. So that's why they are also called hypovalent compound. Okay dear? So अब यहाँ पे how it will get stabilization, ये कैसे stabilization होगा, and there the back bonding concept come in existence. Okay, so now first of all you have to know that why back bonding is needed. Why back bonding is needed. So obviously why anything is needed, जब तक हमें उससे कोई if we are not going to get any advantage from that, it will not be needed, isn't it? So why the back bonding is needed? Similar, any like if we talk about any element, why it completes octet? Because to get the stability. So similarly, this 68 type species do back bonding to get the stabilization. Okay, so what for? To get the get its octet completed. octet completed. Got it? Okay. And BF3 is also to, it wants the electron, isn't it? So since it requires, it needs electrons, so that's why it will act as, hence it acts as Lewis acid. Yes, Lewis acid. The electron acceptor are considered as Lewis acid. I hope it is clear. Yes. And they will, what they will do, they will release some energy in order to get the stabilization. Got it? So they need electron, they will take the electron, and due to this the bond formation will be there, and hence it will release some energy, and if energy is released, that means stability is going to get, isn't it? So that is the way. So hence by releasing some energy, it will get stabilization. Yes, I hope it is clear. So let me, what happens, let me explain the things. Like this is BF3, so this is F, this is F, and here it is F. Okay, let me draw like this. So fluorine is having lone pair, isn't it? So let me draw this lone pair. It is the lone pair. Fluorine is having 7 lone pair, isn't it? So that's why 2 lone pair I have shown over here. Okay, and boron is having empty 2pz orbital, isn't it? This is the empty 2pz orbital. Any problem in this? Okay, so now what will happen? There is, like, you know, everywhere, like if there is the, like, cation, you have seen cation loses the electron, so that's why they have what? They have plus charge. So we can say that then outer orbits electron lose kar diya, that's why they have positive charge. So similarly in class 11th and 12th also you will know this thing, wherever that electron is not there, that part will be considered as positively charged. Okay, so we can say that this is electron deficient, it doesn't have electron over here, and here the electron density is high. This is the positive part, you can say, and there is the electron density high, that means it is the negative, and what it is due to this lone pair, fluorine ka lone pair. So what will happen here, the fluorine lone pair will have the tendency to fill this. Got it? Okay, it will, the positive charge here, this positive part, positive charge, because of deficiency of electron over here, it will act as a positive part. So this will try to attract the lone pair towards it. Got it? And that's why you can see that the bonding is going on, like it's moving in backward side. The bond is forming in the backward direction, isn't it? So that is called back bonding. I hope it is clear. What is this back bonding? So you can say that the bond formation due to the donation of lone pair of F in the empty 2pz orbital of B, boron, is called back bonding here in this case. But back bonding ka matlab hota simply back bonding in the backward direction, bonding in the backward side. Okay, and kaha? Lone pair to the empty orbital. Got it? Lone pair to the empty orbital. Is that clear? So now the thing is that कि कैसे प्रूफ करोगे और कौन बैक बॉन्डिंग करेगा कौन नहीं करेगा, ये सारी चीजें पॉइंट हैं जो कि आपको समझना है. So देखो यहाँ पे एक्चुअली क्या होता है इन द बैक बॉन्डिंग, द पॉइंट इज दैट कि ट्रांसफर ऑफ लोन पेयर, yes, occurs from filled orbital to the empty orbital. Yes, to the empty orbital. Okay, so who will give the lone pair, from where this lone pair? So इसके लिए point दिया गया है, that is FONC. FONC, they are the lone pair donor. lone pair donor. Got it? They only donate the lone pair. So wherever there is like फ्लोरीन, ऑक्सीजन, नाइट्रोजन और कार्बन अगर होगा वहीं पे ये बैक बॉन्डिंग पॉसिबल होगी, अदरवाइज बैक बॉन्डिंग विल बी नॉट पॉसिबल. क्लियर? समझ में आ गई बात? एनी प्रॉब्लम इन दिस? ओके, सो नाउ द क्वेश्चन, आप इजीली इफ आई एम आस्किंग क्वेश्चन इन BF3 and AlCl3, where will be the back bonding? Tell me, very easily you can say. Yes, what? In BF3 back bonding will be there, but in AlCl3 there will be no back bonding, because back bonding occurs only due to the transfer of lone pair by from the filled orbital to the empty orbital, and where it is the FONC, they are the electron pair donor, they are the lone pair donor. So जहाँ ये होंगे वहीं पे back bonding होगी, otherwise back bonding is not possible. Okay, so now the thing is that what are the proof for that? How you can say that yes, back bonding is occurring over there? So what are the proof? So see, if there is no bond, तो यहाँ पे जो distance होगा that will be quite high, quite big, isn't it? But if there is bonding, अगर वहाँ पे कोई bonding होती है तो क्या हो जाएगा? That bond length will be contracted. Yes, bond length will be shortened. Done? Yes. So let's see that if we take the example of BF3. So BF3, if you see here the bond length, ये जो bond length होता है, this bond length, that is some around 1.52 angstrom, and that is its theoretical value. Okay, ये होना चाहिए because it is like sp2 hybridized and इसकी bond angle जो है वो theoretical 1.52 होती है. But when experimentally it is checked, so we got it is 1.30 angstrom, and that is the experimental value. मतलब what does it mean? कि there is some kind of bonding occurring over here. मतलब means single bond. अब यहाँ पे you can see जब ये single bond था and bond angle 1.52 से 1.30 हो गया, bond angle shortened. तो जब भी कभी bond angle shortened होता है, it means it clearly says that the single bond has acquired some double bond character. Got it? Is that clear? Whenever the bond angle gets shortened, it means that single bond has acquired some double bond character. Clear? So how it happens? होता कैसे है? So let me show you. So this is lone pair of electron. So what will happen? It is also having lone pair of electron. It is also having lone pair of electron. Like this. Yes. Okay. So what will happen? Let me show you one lone pair. This one lone pair will shift to this. Yeah. So as a result, what will happen? This boron, here it comes one shifting of two electrons का मतलब एक bond, isn't it? So it will acquire some double bond over here, and since fluorine has lost its electron, so it will have plus charge, and boron will have minus because it has gained. Yes. Now what will happen again? Now ये जो lone pair था, यहाँ पे जो lone pair थे, now this lone pair will move here again. This lone pair will move. So due to this, what will happen? जब ये lone pair जाएगा यहाँ पे, तो ये जो है वो वापस इस पे चला जाएगा lone pair, and this will like same ये चला जाएगा इधर. तो what will happen? As a result, it will give you that now the double bond is developed over here. Okay, and this is boron, and here it is fluorine. The lone pair will be remain like that. Yes, and here ये वापस आ गया, so it will have like this. Now what will happen? अब इसकी वजह से क्या हुआ था? This fluorine has lost its electrons, so it will have plus, and it has taken, तो ये minus sign रह जाएगा यहाँ पे. Got it? What next? अब ये जो lone pair है, this is the lone pair. Okay, why I will be at the back, मैं भी आऊँगा. So this two electron will shift over here. So again, this bond will go back, वापस चला जाएगा, and this will result in this B. ये F वापस चला गया with this lone pair. Okay, and here F, now it is having double bond. and here it is minus charge since it has lost, so plus charge, and this is. So what thing we are saying, that every fluorine is acquiring the positive charge one by one, yes, and every BF bond is going to acquire the double bond for some time, isn't it? So this will result in a resonating structure, and that is like this is F, ये single bond है, and this double bond character is somewhat resonating over like this. So we will draw like this. ये हम ऐसे draw करेंगे. Got it? Is that clear? समझ में आई बात? So this is called resonance hybrid. Now we are going to do this resonance in detail. So don't worry about that. यहाँ try to understand this thing. Resonance hybrid, this is called. I hope it is clear. So now the back bonding can be of p pi d pi and p pi and p pi d pi. Okay, so you have to understand that which type of bonding, back bonding is it is here. Like we can say that bonding boron is boron which electron is participating, all that 2pz, isn't it? And this lone pair is in which orbital of fluorine? Pi p, yes, 2p. So that's why this is called what? This will be called p pi bonding. P pi bonding. Matlab horizontally, see why it is pi bonding. Simple सी बात है, horizontally it is overlapping. Yes, laterally it is overlapping. So lateral overlapping, that means it will form the pi bond, isn't it? It's clear. And since the p orbital is involving, so that's why दोनों का p orbital involve हो रहा है. So that's why we'll say p pi bonding. I hope it is clear. Any problem in this? Yes, please tell me if there is any problem. Yes, okay. So now अब is what will happen with this, ये इससे होगा क्या? So let me show you that. तो यहाँ पे क्या हो गया कि एक और प्रूफ भी है इसका कि पहले जो है अगर हमने देखा था BF3 का, so like this we know that the number of bonds present between the element is called bond order. So according to that the bond order should be 1. Yes, it should be 1. But actually क्या होता है, bond order is somewhat 1.25 to 1.3 के बीच में होता है. Actual bond order is like this. Okay, got it? So it means that there is some some double bond character is acquired by that. How? Let's see. If bond order is high, that means stability is high. So bond length will be shorter. Bond dissociation enthalpy will be more. Yes, this is in the bond parameter we have done. So more the bond order, lesser will be the bond length, and hence more will be the stable, isn't it? Yes. So we can say that we know that more the bond order, lesser will be the bond length, and hence more will be the stability. Yes, any problem in this? So this is the point. So what will happen, ये चीज वहां पे क्या हो गई, because of this pi bond acquiring, और pi bond यहाँ पे आया, कैसे आया? Because of this back bonding. Hope you got it, all the concept whatever I wanted to explain. Okay, अब यहाँ पे एक और चीज है कि like another compounds are also there. Like वहाँ पे ये देखा जाएगा कि जैसे BCl3. If I am taking about the BCl3, okay, so this is BCl3. If you will check the bond length for this, the bond length इसकी जो होगी experimental, it is around 1.87 angstrom somewhat. Okay, this is the what we say theoretical value. But actual bond length जो हो जाती है वो इसकी हो जाती है थोड़ी सी कम हो जाती है, and that is 1.75 angstrom. बहुत कम experimental. बहुत मतलब we can see that it is less difference over here. If you check that BF3 bond length, it is 1.52 से 1.30. a major difference. But if you check for this, it is 1.87 to 1.75, very less. So why it is happening so? Because of यहाँ पे क्या होगा कि chlorine size is bigger. Yes, so bond length is with respect to fluorine, the chlorine size is bigger. Got it? And that's why it will not share the lone pair in that content as BF3 can do. Got it? Any problem in this? So in this case, अब अगर हम देखेंगे यहाँ पे तो BF3 में there was the 2p pi bonding was there, but if you check in this, it will be 2p pi and 3p pi bonding will be there, which is not that much effective as this one is. Hope it is clear. Yes, any problem in this? कोई दिक्कत है यहाँ पे? अब इस पे related बहुत सारी चीजें हैं, like what happens when BF3 is going to react with NH3. So what will be the hybridization change and all that. So that we will also discuss. Okay, so this is one question which is like asked, importantly asked in your exam, that what is the hybridization change when BF3 makes bond with NH3? So see, BF3, if you check that the hybridization will be sp2, isn't it? Yes. And BF3 is electron deficient compound. Electron deficient, that means it needs electron to make the to be stable, isn't it? And NH3 is an electron donor. NH3 is electron donor. So what will happen? This will donate the electron to BF3, and that's why there will be a coordinate bond formed. Okay, so this lone pair will go to this lone pair will participate in the bond. That means we'll say that it is simply NH3 and there is the coordinate bond BF3. So now what is the hybridization? Earlier it was sp2 only, but if you will check this, now the covalency of BF3, earlier it was 3, yes, now it is 3 and one more over here. So covalency of BF3 is increased from 3 to 4, isn't it? Got it? So the hybridization change is, hybridization will be now sp3 and the bond angle will be now 109. Bond angle will be 109.5 degree. Got it? So due to this coordinate bond, there will be what we say, there tendency to be resonating will be decreased. So we can say that due to formation of coordinate bond, due to formation of coordinate bond, it will minimize the resonance. Okay, it will minimize the resonance. Okay, so this is the thing. And what will happen? The bond angle in this case, the bond length, if you'll check the bond length, it is little increased in this case because the bond angle of BF3 is around 1.3, and when it forms a coordinate bond, the bond angle will be little increased and it becomes up to 1.38 some angstrom. Okay, so that is not important, but let me write over here. Bond length will increase from 1.30 angstrom to 1.38 angstrom. Little increment will be there in the bond length. So there are a lot more things for the back bonding, and I will discuss all this back bonding in the next video. We'll share it with you also. So and that is the main thing, that is the important thing which will be needed, which will be asked in your class 11th concept, 11th. Okay, rest something are in details back bonding, that I will make the separate video for that, and you can watch that and get the concept clear. Okay, so that's it for today class, and next class we will do the banana bond and all. So by the time, thank you class, enjoy your study.